So we're out here on Lake Tarawera, and what we're trying to establish is the heat flow that comes up through the bottom of the lake floor. And we believe that there's a large magma chamber underneath the Okataina caldera, and one of the easiest ways to get some very accurate measurements of that heat flow is to in fact work on a lake. That's because we're not impeded by access. Obviously the lake floor is not covered by forest, and it's 100% exposure, so we have a really good opportunity to get first-class data from instruments we put on the lake floor. So today we deployed heat flow blankets. They're a design made out of the University of Washington in the US, and they're very simple really. They're a bit like a cricketer's floppy hat. They can range in diameter, but ours is about 70 centimeters across. So we know the diameter, we know the thickness of sponge that's included within them, and we have a thermistor underneath which sits very snugly on the lake floor, and we have a thermistor on the top which is recording ambient temperature. So we'll measure those both over say 24 hours, and we can get the difference between the two so we can work out a flux for the heat. So far we've been working extensively on Lake Rotorua, and now just this week we've been working on Lake Tarawera. And both of them show a very high propensity for heat coming through the bottom of the lake floor, so that's good. It means what we're doing has some relevance. And what we're finding is that there's a very large geothermal system that's extending from Waimangu through Lake Rotorua and probably just into the very southern part of Lake Tarawera. So ultimately what we want to do is to establish the heat coming out of the 7 lakes that cover or sit on top of the Okataina caldera, and then multiply that for the aerial extent of the caldera itself. Equally, what we want to be able to do is to get a theoretical calculation of the heat going in underneath this area as the place is extending as part of the Taupo volcanic zone, and we can calculate how much space that would be, if you like, and it would be filled by basalt. So we can calculate a temperature that should be that should be at the bottom of the caldera, and we'll measure the temperature that's coming out of the caldera. And if there's a difference, and we suspect that maybe there will be, and i.e. there's less heat coming out than what is going in, then that would be a very firm indicator that there's a magma chamber building up underneath this caldera. It's worked perfectly well, and with a bit of luck we'll have about 130 stations here after about 3 weeks work. And this is the biggest of those 7 lakes, and once we've done this lake we'll move on to the next.